In grade 6, we expand our work with positive and negative numbers to include rational numbers. This huge group includes all the integers, the whole numbers and their opposites, plus all the fractions and decimals, both positive and negative. Our job is twofold. We need to confidently locate and order these numbers on a number line, and we need to understand the concept of absolute value, which is just the distance from zero. The rational number line is our most powerful tool. It extends forever in both directions, allowing us to plot every fraction and decimal. The most critical takeaway from the number line is the comparison rule. Numbers always increase in value as you move to the right. No matter how complicated the numbers are, if one is to the right of the other, it is the greater number. To compare any two rational numbers, you just ask yourself, which number is farther to the right on the number line? The number on the right is the greater number. Conversely, the number on the left is the lesser number. This single rule works for two positives, two negatives, or a positive and a negative. Let's apply the rule to example 1, comparing the decimals minus 1.5 and minus 1.25. Both are negative, so they are to the left of 0. However, negative 1.25 is closer to 0 than negative 1.5, which means it is farther to the right. Therefore, negative 1.25 is greater than negative 1.5. The symbol is the greater than sign. When comparing fractions, like in example 2 with 3/4 and 7/8, the easiest method is to find a common denominator. We convert 3/4 to 6/8. Now we compare 6/8 and 7/8. Since 7/8 is clearly the larger positive value, 7/8 is greater than 3/4. Comparing negative fractions is trickier, but the common denominator method still works. The key is remembering the number line rule. When they are both negative, the one closer to 0 is the greater number. Once you find the common denominator, just remember that the number with the smaller negative numerator will be closer to 0. In example 3, we compare negative 2/3 and negative half. The least common multiple is 6, so negative 2/3 becomes negative 4/6, and negative half becomes negative 3/6. Since negative 3/6 is closer to 0, negative 1/2 is greater than negative 2/3. To order a list of mixed rational numbers, say fractions, decimals, and integers, you first need to convert them all to the same format, usually decimals. Once they're all decimals, it's much easier to imagine their position on the number line. Then, you simply list them from the smallest value, farthest left, to the largest value, farthest right. Let's order the list in example 4, 0.5, negative 3/4, 1.25, and negative 2. We convert the fraction to negative 0.75. Now we order the decimals, negative 2.0, negative 0.75, 0.5, and 1.25. Finally, we write the original list in order, negative 2, negative 3/4, 0.5, 1.25. Now let's talk about absolute value. Absolute value is simply the distance a number is from 0. Because distance can never be negative, the absolute value is always positive or 0. We use two vertical bars to show absolute value, like x squared. If you drive 5 miles east or 5 miles west, your distance traveled is 5 miles in both cases. That's absolute value. The rule for the absolute value of integers is straightforward. The absolute value of any non-zero number is just its positive form. The absolute value of negative 10 is 10. The absolute value of 10, negative 10 is also 10. They are both 10 units away from 0. This rule also applies to fractions, as seen in example 5. The absolute value of negative 2/5 is 2/5. The absolute value of 2/5 is also 2/5. The number of units away from 0 is the same, regardless of the direction. The same goes for decimals in example 6. If you find the absolute value of negative 3.7, the absolute value of negative 3.7, the answer is simply 3.7. The negative sign only describes the direction, and absolute value only cares about the distance. You might be asked to compare absolute values. Remember, you aren't comparing the numbers themselves. You're comparing their distances from zero. First, find the absolute value of both numbers, and then compare the two positive results using the greater than or less than signs. Let's compare the absolute values of negative 5 and 4 in example 7. The absolute value of negative 5 is 5. The absolute value of 4 is 4. Now we compare 5 and 4. Since 5 is greater than 4, we conclude that the absolute value of negative 5 is greater than the absolute value of 4. In example 8, we compare the absolute values of two negative numbers, negative 1.5 and negative 2. The absolute value of negative 1.5 is 1.5. The absolute value of negative 2 is 2. We compare 1.5 and 2. Since 1.5 is less than 2, the absolute value of negative 1.5 is less than the absolute value of negative 2. Absolute value is especially useful in finance. If you have a debt of negative $20, the bank cares about the absolute value, $20, which is the actual amount you need to pay back. The negative sign just indicates the nature of the number, while the absolute value indicates the magnitude of the debt. We use these concepts for temperature as well. The temperature with the higher value is warmer, and the lower value is colder. The absolute value of a temperature tells you how many degrees the temperature is away from the freezing point, 0. A temperature of negative 5 degrees is 5 degrees away from freezing. It has an absolute value of 5. Example 9 is a real-world ordering problem. We have 4 divers at depths, negative 10, negative 15.5, negative half, and negative 11 meters. Deepest means the least value. Ordering them from least to greatest depth, negative 15.5, negative 11, negative 10, negative half. For your final challenge, consider the list 3, negative 5/4, 0, and the absolute value of negative 1.1, the decimal of negative 1.1. First, simplify and convert all to decimals. Second, order the original list from greatest to least. This challenge requires you to use all the concepts, ordering, conversion, and absolute value, all at once.